Hello guys, in this video we are discussing a very important problem, that is longest common prefix. So basically you are given a set of strings. You are given a set of strings and you want to return the longest common prefix. What is the longest common prefix? Let's see this with this test case. There are three strings. We want to find out the substring which is common to all the strings. If you see, and the substring should be largest. Maybe the substring may be the entire string in some cases. That doesn't matter for us. But we want to return longest as much as possible. If you see, flow is common in all. Flow is common. Here the flow is common. Here flow is common. But here flow is not common. So it is not the longest common prefix. Now if you see, FL is common, FL is common, FL is common. So we came to know that for all the three strings, the longest, as much as possible, the longest is only FL. The longest is only FL. Now, how can we approach this problem? I think you guys understood what the problem statement is. I think there is no much to explain the problem statement, but the approach is very important. Approach is very important. First, let's think the one. Let's think one logic. Let's think one logic. Okay. First, whatever may be, if you want to perform a common prefix, if you want a common substring between all the strings which is largest, that should be common in all the strings, right? So first what I am taking is, first I will take the base string which is base. I will iterate this string. So I am considering the base string which is flower, the first string. First I will consider the first string. First string flower. So let me give the indexes. Now I will start iterating from 1 to n. Okay, just this. First I will check this f, whether f is, whether in the zeroth position, in this zeroth position for all strings, whether the f is there or not. See, here there is a 0. At zeroth position in all strings there is f. That means is currently my substring f is the longest, but I don't know, in future I may get L, I may get O, I may get W, but I don't. But currently I checked F to all the strings. Now in the second point I came to here. Now L, check at first position in all the strings. So at first position in all the strings L is there or not. So in first position in all the strings there is L. So add L to F. Now FL become the common prefix, but in future we may get more substrings, so we should check for O also. Check for O in second position. Check in second position in all substrings. So in all the strings whether there is O or not. Yes, here there is O, but here there is I. So there is, that means that is not a common. There is no common. Here O is satisfied, but every string should have common, right? So the point, this is the point where the common substring between all the strings ends. This is the point. At the second position, At second position, this is the point where the there is no common substring between all the strings in the array. So this is the point. That means I find out this point. Now, of course, the common substring will become and longest. Of course, the longest will become this only, right? See, if you find out that at certain point there is no common, that means the longest will be this only, right? Of course. So this is the logic behind this. We are iterating the first string of the array, and we are checking each and every character in the positions whether these are equal or not. Now let's see the code. Now let's see the code. First, what are we doing? Just a minute. Yeah. First, what are you doing? We're just iterating. We're just considering this as a base string. This is called base string. This is called base string. We will iterate each and every element in the string. We will see whether the f in that position, in zeroth position, in certain ith position, whether the same character is there not or not in all the strings in the same position. I'm again repeating. So first, this is the base condition. So we see whether the string is null. If string is null or string dot length is equal to 0, then we should return the empty string. Now we should traverse this string. So I am traversing the first string of the array. So I is equal to 0 to string of 0 dot length I plus plus. Now I am checking each and every character. Current this is one. I am checking each and every character in the first string of the array, and we will check in the same position whether for the remaining strings the character is same or not for the same positions. So I will traverse from here. This is the internal loop. This is jth loop. I will traverse from here. So in the same ith index, we will check whether the character is equal or not. If character is not equal, then that is the point where the common what we can do where the common prefix is not there. That is the point where the substring of the common substring will end in the string. You can also say that is the point. So when it ends at certain point, in this case it ends at this point, so we will return from 0 to this substring. So we will return a 0 to ith substring. Now in the last situation, there is a chance of that this whole string will be the longest common prefix. So we return strings of 4. Okay, this is a easy code, no need to explain much. You can try because you know the approach. So now what is the time complexity? Time complexity here is order of n square. N square is my time complexity here. So n square is my time complexity. So can I decrease the time complexity? Let's see. How can we decrease the what idea makes me to decrease the time complexity? Okay. Now let's see the optimal approach. How can we optimize this solution? In previous approach, the same as the previous approach, but a bit optimizing. Flower. Okay. Let me write here. Okay. A flower. Here I am iterating to every position. First I will go to F and we will see in entire array in that position F is there or not. The same L, O, W. The same thing I am doing. I'm going to each and every iteration. I'm going to each and every iteration, each and every point I'm going. I'm iterating each and every character. So my question is this seriously required to iterate the entire string? Think, is this seriously required to traverse the entire string, entire character, each and every character? The answer is it is required, but not compulsory. So you can do without traversing the each and every character. This idea comes here is binary search. Binary search. How the binary search is working? Binary search is optimization of the linear search. In linear search, we are going to each and every element in array or string, but in binary search, we will not go to each and every element. But this is not sorted. But the idea is, I will tell how can we use binary search. Why binary search is required here? Why binary search is required here? No. Okay. Let us find the mid. Now, flowers. Let's take flowers. Okay. Let's find the mid. I'm just taking here as flowers. Okay. For my comfort purpose to explain easily. So, for binary search, first I am considering low as 0, as you guys know, high as 6. Now I am finding mid. No, my mid is W. My mid is W. My mid is W. So my mid is W. Check if this entire substring from 0 to 3 is a common prefix or not for every string in array. 0 to 3 especially. Check. 0 to 3 means flow, right? Check here flow is there. Of course here flow is there. Here flick is there from 0 to 3. That means that is not a common prefix. That is not a common prefix. Now, if up to here, if this is not a common prefix, for all the elements in the array, what I came to decide, that means 100% sure that there will be no common prefix from 0 to this indexes. I am 100% sure that this is the place which is not required for us. Now, what can we do now? If from here to here, this is not a useful part for us. That means I should check this part. I should check this part, right? I should check this part. Now, my high becomes mid minus 1. Right? My high becomes mid minus 1. Now, this is not required for us. Just remove it. This is not required for us. I'm just imagining. Remove it for your comfort purpose. Okay? Yeah. Now, this is low. This is high. O is high. Now, find the mid. Now, my mid part is L is the mid part. So, from 0 to 1, check the common prefix is there or not in the entire array. From 0 to 1, check the common prefix is there from or not from 0 to 1. So 0 to 1 is of course FL is there common. From 0 to 1, of course FL is there. So the common is there in all the strings in the array. That means S. Of course, there is a common, but I am not sure now. No, I am not sure. I am not sure that this is the longest. FL is my answer. Of course, FL is my answer, but I am not sure that this is my answer. In future, there may be a chance of we want longest, right? We want longest. So there is a chance in right side there is a common. There is a chance, but not sure. But there is a chance in right side there will be the longest common prefix. So I just thought currently FL has my longest common prefix LCP. I'm just throwing, but I'm not sure. But where should my uh, where should my binary search? Where should my direction should go? And which direction it should go afterwards? If I find the common prefix, then what should I go? You should go right, right? You should go right. You should go right. Because as much as right you will go, then only you can find the longest. So what we will do is, my low will increase to 1 now. So my low will increase to mid plus 1. So my low will increase to mid plus 1. So my low will increase here. Low and high. Now check. Low plus high divided by 2. So mid will come only. Again, FLO is not there here. FLO is not common. FLO is not common. FLO is not common. FLO is not common. So if it is not common, no. High becomes here. Low is here only. So low is here. High is here. Means high crossed the low. High is greater than low. This condition should not come. If this condition came, that means your binary search is over. That means I got FL. In simple terms, what I am telling is, we are considering the base string. We are base string from n-1. Where they're finding the midpoint. We're just finding the midpoint. If 0 to mid substring is common for all the strings in the array, is common from all the strings from 1 to n in the array. If it is common, what you will do? If it is common, what you will do? Let us suppose A, 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 A. Okay. Okay. Let us suppose there are these two strings. Now I am considering this base string. So I am doing binary search with this string. Okay. This is low. This is high. Let us suppose my mid is this from A to A. My 0 to from 0 to mid. Mid here is 2. Check for remaining strings whether from 0 to 2 same or not. From 0 to 2 it is same. Yes, common prefix is there from 0 to 2. But this is not the answer. But this is not exact longest. There is a common but not longest. If you want to find longest, you should move as much as right. Because you can see there is a common here also. We are missing. So if it is equal, we should go to right side. So my low will become mid plus 1 high. Now we will check. Same like that. We will go to right side. So if there is a common, you should go to right side. If common, you should go to right side. If mid is not common, if from 0 to mid there is no common prefix in the array, you should go to left side. If here it is not there, should go to left side. As much as left side you should see. That's the logic. So okay, I will show you a code now. You will understand much clear. Yeah, this is the code. First, I'm taking low is equal to 0, high as n minus 1, high is n minus 1. Now, I'm considering the last index which is common. So this is the last index initially minus 1.